We are asked to calculate the number of moles in a 1.52 kilogram sample of glucose. So like always, pause this video and try to figure this out on your own, and this periodic table of elements will prove useful. Alright, now if we're trying to figure out the number of moles, remember, mole is really, you could view it as a quantity of something. If I said a dozen of something, you'd say, oh, that's 12 of that thing. If I say a mole of something, I'm saying that's Avogadro's number of that thing. And so we have a 1.52 kilogram sample of our molecule in question, of glucose. So if we can figure out the mass per mole, or another way to think about it, the molar mass of glucose, well, then we just divide the mass of our sample by the mass per mole, and we'll know how many moles we have. So what is the molar mass of glucose? Well, to figure that out, and that's why this periodic table of elements is useful, we just have to figure out the molar mass of the constituent elements. So if we first look at carbon, we see from this periodic table of elements, has a molar mass of 12.01 grams per mole. We've talked about in other videos, you could view this 12.01 as the relative atomic mass of a carbon atom, as the average atomic mass of a carbon atom, or what's useful, and this is where Avogadro's number is valuable, if you have Avogadro's number of carbons, it is going to have a mass of 12.01 grams. So carbon has a molar mass of 12.01 grams per mole. And now we can think about hydrogen in the same way. Hydrogen has a molar mass of 1.008 grams per mole. 008 grams per mole. And then last but not least, we have oxygen here. Oxygen, we can see from our periodic table of elements, it has a molar mass of 16.00 grams per mole. And so now we have all the information we need from our periodic table of elements. So the molar mass of glucose is going to be 6 times the molar mass of carbon, plus 12 times the molar mass of hydrogen, plus 6 times the molar mass of oxygen. So it's going to be 6 times 12.01 grams per mole, plus 12 times 1.008 grams per mole, plus every molecule of glucose has 6 oxygens, plus 6 times 16.00 grams per mole. 6 times 12.01 plus 12 times 1.008 plus 6 times 16 is equal to, and if we're thinking about significant figures here, the molar mass of hydrogen goes to the thousandths place, but we only go to the hundredths for carbon and for oxygen. We're adding all these up together. So it's going to be 180 point, I can only go to the hundredths place for significant figures. So 180.16. So that's equal to 180.16 grams per mole. And we could say grams of glucose, C6H12O6, per mole of glucose, C6H12O6. And then we can use this 1.52 kilograms to figure out how many moles we have. So if we start off with 1.52 kilograms of glucose, so that's C6H12O6, well, first we can convert it to grams, because here our molar mass is given in terms of grams. So times, we're going to want kilograms in the denominator and grams in the numerator. So how many grams are there per kilogram? Well, we have 1,000 grams for every 1 kilogram. So when you multiply these two out, this is going to give you the number of grams we have of glucose, which would be 1,520. And if you have your mass in terms of grams, you can then divide by your molar mass, or you could view it as multiplying it by the moles per gram. So for every 1 mole of glucose, C6H12O6, we have 180.16 grams of glucose, C6H12O6, and this is going to get us, we get 1.52 times 1,000 is equal to, this is the number of grams of glucose we have, and then we're going to divide by 180.16. Divide by 180.16 gives us this number. And let's see if we see significant figures. We have 3 significant figures here. We have 5 here. So we want to round it to 3 significant figures. So it will be 8.44 moles of glucose. So our kilograms cancel with our kilograms, and then our grams of glucose cancel with our grams of glucose, and we are left with 8.44 moles of glucose. Moles of C6H12O6. And we are done.